going to be manipulating equations, which what that really means is we're going to be working with literal equations. We're going to be rearranging formulas or equations that have a lot of variables into a different form. So we're going to start just by reviewing how do you just solve a regular equation. So we've got 4 different equations. It looks a little bit different. They're all linear equations. We know they're linear equations. They're one variable, no exponent other than 1 on that variable. For all of these, they ask us to solve for x. X is the only variable in there. They wouldn't even have to tell us what to do. We'd know what to do, right? So that's what we're going to do first. We are going to solve number 1 for x. That means get x by itself, right? But what is x? If we get the right answer, how will we know we get the right answer? What does it mean to have this by the solution or to solve for x? We do know it's going to mean x is going to be by itself, right? What does it mean to solve? What is the solution to an equation? X is going to equal a constant. What will we know about that constant? Yeah, what makes it the solution? That's hard to say, right? So the solution will, when you replace x with that value and multiply by -2 and add 11, it'll equal 15. That's all that means. So when you plug the solution to an equation in, sometimes they say it will satisfy that equation. And that means the left side will be equal to the right side. Or if that means that it will be a true statement. There's a lot of different ways to say that.
Interruption. All students that were taking the ASVAB are returning to class at this time. Thank you.
So when we solve for x and we get it by itself, if we have done it correctly, we can plug it back into that equation and it will make the left side equal to the right side. That's what it means to solve an equation. Now, it won't be the same when we're manipulating or solving a literal equation for a variable. We're going to talk about that in a second. But first off, can you read me this equation? What is this equation? Okay, can you read me that equation?
Just read it?
Yeah.
-2x plus 11.
Did you just get your picture? You need to go down and check in, buddy. Yeah, so -2x plus 11 equals 15. So when we solve an equation, we have to undo what's happening to the variable. Do you guys remember having it described that way? We're going to undo adding. Is there anything else we need to undo? Because when Kate read it, and every person that has to read this equation is read it the same way then. -2x plus 11 equals 15. What does -2x mean? What's that operation that's happening there that we didn't say? Yeah, it's 2 times x. -2 times x, right? So we have to remember -2 times x plus 11. We've got to undo the addition and also undo the multiplication. You don't see a symbol there. I could pick these out. We don't see a symbol there, but we do have to know we have to undo it. And most of the time, we're always going to undo addition and subtraction first. So that's what we're going to do here. We've got x on the left side. We need to undo the multiplying by -2 and undo the adding 11. We're going to start by undoing the adding. We're going to undo adding by subtracting. So we've undone the adding. Now we're going to undo the multiplying. How do we undo multiplying? By dividing. So what do we need to divide by? 4? -2, right? That I will have some kids come in 4 sometimes, so be careful. But remember, the whole idea is to get x by itself. So if you start on the side where x is not, you're not doing anything to get x by itself, right? So always want to look over your variable. You're going to divide by -2. And now we know x equals, is -2. We're going to check this one. I'm not going to make you check the rest, but we are going to check this one. Remember, checking it just means we're going to plug it back in and see if it satisfies that equation or makes that equation a true statement. So it's -2 times what our x is, right? And that's -2, so we're going to plug in -2 plus 11 equals 15. -2 times -2 is +4. And 4 plus 11 is 15. So we know that our solution is correct. Okay? So now this one looks a little bit different. Got a fraction and parentheses in it. And we want to get rid of the fraction. We're going to multiply by the reciprocal. What does it mean to multiply? Oh, that's not what I want to get rid of. I wanted to cover up that problem number. It's not my way. Okay. So if I want to, so I've got 1/2 times 3 times x minus 1 equals 7. So I've got 2 times, right? If this were a whole number, we would just distribute it. Remember how to distribute it? But if we distribute it here, then we're going to have a fraction in 2 terms. If we just go ahead and get rid of this fraction, then we don't have to mess with the fractions anymore until the very end, possibly. Maybe not even then. So what does it mean to multiply by the reciprocal? Mason?
What about the opposite?
The opposite would be -1/2. Flip it, yeah. So we're going to flip that fraction, or flip that number. If it were 2, that would be the same as 2/1, and we flip it. But the reciprocal of 1/2 is 2/1. We flip that fraction. So maybe remind yourself you're just flipping the fraction. So why do we do that? Well, when we multiply by the reciprocal, now we're going to get 1, and that's actually the definition of reciprocal. The reciprocal of any number is the number you multiply by it to get +1. So flipping the fraction does that, and multiplying by that. So let's do that. So we're going to multiply this 2 over 1. This is a little bit tricky if you'll remember. If you're multiplying an entire equation by a number, and there's a number on the outside of parentheses, we only multiply it by those parentheses. So 2 times 1/2 is 1, and we bring the 3x minus 1 down. It's equal to, now we can't forget, we're going to multiply it by 7 as well. I just did that for illustration, just so you can see what's happening. We really don't need that 1 there, do we? So really what we have is 3 times x minus 1 equals 14. What are we going to do to solve it from here? Connie, what do we do to solve it from here? So we're going to undo 3 times x minus 1. Remember we said we're always going to do undo addition or subtraction first. Perfect. We're going to add 1 on both sides. So I'm going to go get this and run out of room. 3x equals 15. Now we divide both sides by 3. And now we know that x equals 5. If I plug 5 into there, will I make the left side equal to the right side? I'm not going to make you write it down. And I'll tell you 3 times 5 is 15. Minus 1 is 14. What is 1/2 of 14? 7. So that would make our equation a true statement. It would satisfy the equation. So that's always the goal. So this one's still a linear equation, but this has variables on both sides, right? Anybody remember what you do if you have variables on both sides? Yeah, so we're going to either subtract 6x from both sides, or we're going to add 3x to both sides. Technically, either one would give you the right answer. I will tell you, if you subtract the biggest one, you're always going to have a negative coefficient on your variable. And 1/3 of the time, kids are going to mess up that negative. So if you always add the opposite of the smallest one, the smallest coefficient, then you'll always have a positive coefficient on your variable as long as they aren't both negative, right? So we're going to have 9x plus 4 equals, this is the part that messes up a lot of kids, it's not 5, right? Minus 5 means the sign on that 5 is negative. Minus 5 is the same thing as plus negative 5. You've got to remember that that's negative 5. Here we're undoing 9 times x plus 4, so we're going to undo the adding again. What am I going to do here, Lawson? Yes. So 9 times x equals negative 9, and once again we're going to undo the multiplying by dividing, making sure we look to the side where the variable is to decide what to divide by. So x equals negative 1. I plug in that here. 6 times negative 1 is negative 2. Negative 6 plus 4 would be negative 2. Negative 3 times negative 1 is 3. Positive 3 times 5 would give me negative 2. So negative 2 equals negative 2. We know we have the correct solution, right? Well, we have the only solution. Anything else would not be a solution, right? And last, a little bit more complicated looking. We've got parentheses. We've got x's all around here. Anytime we have parentheses inside an equation, we do want to distribute and get rid of those parentheses. Don't want to fraction at least, thank goodness. So I'm going to work left to right, and I want to distribute this. But this is too easy to not go ahead and combine it first. So we're going to combine that when we bring down to our next step. 4x's plus 2x's is 6x's. Now we're going to distribute negative 5 times x. That's minus 5x. Negative 5 times negative 3. The mistake a lot of kids make here are, number one, they don't multiply the negative 5 by that negative 3, or they multiply it by a positive. So make sure negative times a negative is a positive. 5 times 3 is 15. We can't start undoing anything when we have terms we can combine. So 6x's minus 5x's gives me 1x. And now we have a one-step equation. That means we just have one operation to undo to get it by itself. We're going to undo adding 15 by subtracting 15. And that is the solution for number 4. So we reviewed how to solve these equations because we're going to use the same steps for manipulating or rearranging literal equations. We're solving for any of the variables is something we should be able to do. Any of the variables in a formula in particular. Y'all caught up with me? Okay. So this equation and this equation, look at them and see what you think. Hopefully you know this is very similar, except this only has one variable and this is all variables, right? This is the product of two values, and that's a product. So that's 4 times x, a times b, plus a constant. So I'm going to change plus 5 plus c is equal to a constant, equal to a constant. D, we're not multiplying or dividing anything there, right? So they're very similar. You could say they're kind of parallel, except this one would be considered a formula or a literal equation. So the first thing we're going to do, we're going to put some things down here and compare the steps. The steps here for solving this equation for x are going to look exactly the same as solving this equation for b. So here we already knew we're supposed to solve that for x. When you're rearranging literal equations or solving for a variable, they have to tell you which one to solve for. Because we can, in theory, we could solve for a, b, c, or d. So we have to know which one to solve for. Solving for b means getting b by itself. And we know that solving for x means getting x by itself. Right? We've done that a bunch. So what's the first step in this equation, Miana? To solve this equation for x. That's exactly right. So we're going to subtract 5. from both sides. And we have 4 times x equals 20. Now, here, if we're solving for b, one thing I always ask kids to do, and when I'm solving for a variable, I always circle the one we're solving for. Because it's a random thing. They just told us which one. We have to remind ourselves at each step, which one are we supposed to be getting by itself. So here, a times b plus c equals d, we're going to undo the same thing. We're going to undo that adding to that term, so we're going to subtract c from both sides. So we're doing the same thing, but it's going to look at different a result because we can't simplify any of these things. They're not the same thing, right? They're not like terms. So c minus c leaves us just with a times b on the left side, and d minus c leaves us with d minus c. Math we can't do because we don't know what d and c are. I'm going to circle my b again. And then, what do we do here to solve for this one? What do we do here, fellas? Yeah, what do we divide by? Yes. So we're dividing by the number that's being multiplied by the x, so that's going to leave us x equals 5. So we divide each side by 4 to isolate x. What do we need to divide AB by to isolate b, to get b by itself? Madeline? What's being multiplied by b? What's being multiplied by b? So is that, this is what we have. Yes, a is being multiplied by b, so we divide by a, because remember the whole idea is to get the b by itself. So we have b equals d minus c, all divided by a. We can't do anything else. We can't combine anything else, but our b is by itself now, and that was what we were supposed to do. Divide each side by a to get b by itself. So the whole point of this little slide is that we don't do anything differently. The only thing we do have to know what variable they want us to get by ourselves, and they have to tell us that. And then we have to remember which one it is through every step. All right. Ready? So it says basically what I just said. The steps for the two problems we just did are basically identical. The only difference is that one had only one variable and the other had all variables, right? And the other thing is we knew what to solve for in 4x plus 5 equals 25. There's only one variable. But if there's a bunch, then they have to tell you. So here they tell us, solve for y. So step 1, find and combine. So if we could combine any like terms on either side, we would do that. Find just means let's mark it somehow. Let's circle it, let's underline it, let's highlight it, let's do something so we can remember which one we're supposed to be getting by itself. So once we know which one's by itself, we're going to undo addition or subtraction before we undo multiplication or division 99 times out of 100. Not every time, but most times. So we're going to add or subtract to get y by itself. This is z times x plus v times y equals r. So the y term is what we're looking at. We can't see variable term anymore because they're all variable terms, right? So what do we need to add or subtract from the by term? What do we need to add or subtract from that term, Soraya? What's being added to it? Well, let's rearrange it. Could we say b times y plus z times x equals b times x? Isn't this the same thing? Now what's being added to the y term? Yeah, so that's what we're going to subtract. We're going to subtract dx from both sides. So when we do, now there's no longer a dx on the left side. I'm going to remind myself, see, I almost circled the b. We're solving for y. And what we have over here now is r minus dx. Now we need to multiply or divide to get that b away from the y. So what are we going to do here, Adrian? This is b times y. So undoing multiplication. How do you undo multiplication? Divide it, right? So you undo multiplication by dividing, you undo dividing by multiplying. We undo addition by subtracting, and we undo subtraction by adding. So we're going to divide both sides by b. And y equals r minus b times x, all divided by b. And we can leave it just like that. We can't really check these answers like we can check a regular linear equation because we can't plug it back in. We know we're done when we've got the variable they asked us to solve for is by itself. Our y is by itself. If we did all of our steps correctly, then that should be the correct answer, right? Any questions on that? All right. We are going to solve for d. So this is kind of the same thing. If you want to rearrange it and put that variable term first, you can. You don't have to, but it makes more sense to some people if they do. Because now we know that AB is being, it looks more obvious that AB is being added to CDE. So what are we going to do? Mason, what are you going to do here? Are we solving for D? Yeah, subtract AB from both sides. So now we have CDE equals SG minus AB. Reminding myself again what I'm solving for. D needs to be by itself. C times D times E. So I'm doing multiplication, and I can actually undo this multiplication for both C and E together. So I can divide by CE, divide by CE, all in one step. C divided by C simplifies to 1, E divided by E simplifies to 1. Then D equals FG minus AB all over CE. If you can solve an equation, you should be able to rearrange these literal equations, solve for a different letter. Which variable is number 2 solved for right now? What is it already solved for? P, right? P is by itself. So right now, just look at the visitor schedule. Will you put your phone in your backpack for me? Alright, we want to get y by itself. So this one is a kind of an exception to the rule here. We want to get rid of this fraction first. Ms. Taylor says kill the fraction first. I'm not exactly sure why, but it's in there, so we'll use that. Kill the fraction first just means we're going to get that b out of the denominator here. It's been dividing by b, so we can get the b out of that denominator first by multiplying by b. This is the one time you can't subtract the x first. If the variable we're solving for is in the numerator or denominator of a variable, we can't undo addition or subtraction first. So these are going to simplify to 1. What we have left on the left side is x plus y. What do we have left on the right side? What do we have left on the right side, Sanaya? What do we have left over here? Yes, and how are we going to write it? Yeah, just PB. And so, once again, solving for y, that's y plus x or x plus y, so we're going to subtract x from both sides. And y equals PB minus x. Y equals P times B minus x. If we kill the fraction first, it will look a little bit different when we multiply to get 1/2 away earlier. I don't like to work with fractions. We can go ahead and multiply by the reciprocal to get rid of this fraction. Now this one has no parentheses in it, so every term gets multiplied by the 2. 2 times 1/2 is 1 HK, plus 2 times 3 is 6, equals 2 times x is 2x. We don't need the 1. It's just h times k plus 6 equals 2x. And we need to make a note that we're solving for k. We need to mark what we're solving for so we don't forget. So I've got not all variables here. I have 3 variables and 2 numbers. But I still do the same thing. So whatever's being added to the h times k, I'm subtracting from both sides. So that is hk equals 2 times x minus 6. The k is going to be by itself. What do I do? What's my last step to get it by itself? Layla? Yeah, we write everything by 8. So that's k equals 2 times x minus 6, all divided by 8. This is a linear equation in standard form, and we're just working with these, right? If we solve this one for y, we're actually writing it in slope-intercept form, which we've been doing. Right? So this one's going to be hopefully a little bit easier. We're solving for y. Remember, what's being added to the y term is 2x. And do adding by subtracting. So we'll have 3y left on the left side, negative 2 times x plus 6 on the right side. What's our last step? What's our last step, Kalani? So y is going to be by itself, right? So what's left with y? What's still with y? 3, that's right. Is it being added, subtracted, multiplied, or divided by y? What's 3y mean? Does it mean we're multiplying them? We're going to divide them, but that's because they're being multiplied, right? So 3 times y, we undo by dividing. We want the 3 gone, so we divide by the 3. So what we have left is y equals this. But we've got 2 constants here. We don't really want to leave it in this form when we have 2 constants. Remember, that's the same thing as negative 2x divided by 3 plus 6 divided by 3. These 2 are exactly the same thing, but I want to be able to simplify this one. So I wrote it, I separated it. So now the final answer should be y equals 2 times x divided by 3 plus 2. Or y equals 2/3 x plus 2. So we went from standard form to slope-intercept form. Okay? If you look at your worksheet today, you don't have to do all the problems in the front. You've read the directions. They give you problems that are worth a certain number of points. You just have to do enough problems that you have 5 points. Right? The harder problems or more complicated are worth 3 points. The simpler ones are worth 1 point. Right? You can do all 3 easiest ones and then 1 2 points, and you would be done. You would not have to do the 2 bottom hard ones. You can do all of them. It would be great practice, but you don't have to. Too much is not a problem, but too little is. submit our notes first? Then yes, you can. I'm going to scan and submit our notes. Go ahead and scan and submit your notes. Remember, I'm not going to grade all the notes, but I am going to go back and spot grade them. If you're here and they're done, you might as well go ahead and scan and submit them. What's wrong, Mason?